In this video we're going to solve Math Tutorial Sheet 3 2025. Now you do well to subscribe to our channel so that you don't miss out on the solutions for every tutorial sheet. Without wasting time, let's start with the first question. Now the first question is complete the square of the following expressions. X squared plus 4x. Okay, those are the expressions. Let's start with the first one. So our first expression is x squared minus 4x. Okay, now how do you complete the square? You know, to complete the square for each expression, you need to add and subtract the coefficient of the, or let me say the square of the half of the coefficient of the linear function. A linear function is y is equals to mx plus c. So the one that has x is the one that you have, and you add and subtract and you square that. So this is the linear function in that case. So let's just do that. So what are we going to have? The coefficient in that regard is 4. When we half this, we're just going to find 2. Now squaring it 2 will give us 4, right? Now we're going to add and subtract that. Okay, so what are we going to have? We're going to have x squared minus 4x. Then we're going to have plus 2. Okay, we're going to square this and we're going to say minus 4, or let me also say just minus 2 squared. Okay, so let's just do that. Now what we are going to now do is we're going to ignore this, the one that we've halved, and we're going to put the ones with the squares in one bracket. Okay, so let's just do that. So we're going to have x plus 2, this will be squared, okay, minus 2 squared, that is just a 4. Therefore when we reach here, we've completed the square. Let's solve the next question. Okay, the next question is x squared minus 6x. Okay, so let's just do that. So we are saying number 2 is x squared minus 6x. Okay, so we are just going to do the same. So we're going to get the negative 6. We're going to find the half of that. That is just a negative 3. So we're going to square, this negative 3. That will just give us a 9, right? So we add and subtract 9. So in that regard, what will be our answer? So we have x squared minus 6x. When we add and when we subtract, okay, so what are we now going to have? We're saying we're going to say negative 3. This will be squared, and we're going to minus that negative 3 squared. Okay, so what are we now going to have? We ignore we ignore this, and the ones with the squares, we put them in one bracket. Okay, so we're going to say x minus 3, we put that in bracket, okay, minus negative 3 squared, that is just a 9. Okay, we've expressed in completing the square. Now I must make mention that you want it to be in the form a x minus p or plus p, this is squared plus q. This is the original form that you're trying to achieve. So even in this case, that's what we've done. Let's go to question number 3. So that is 2x squared minus 5x. Okay, let's just do that. So we're saying we have 2x squared minus 5x. So how are we going to solve that? Okay, so solving this one, we're going to factor out 2. So when you factor out 2 of x squared minus, we have 5 over 2x. Okay, we factored out 2. Then we're going to again find the half of that and square it. Okay, we're going to find the half of that and square it. So let's just do that. Okay, so negative 5 over 2 multiplied by half. What are you going to have? You are going to have negative 5 over 4. Okay, so you are going to square this as well. So what are we going to have? We'll have x squared minus 5 to x, okay, plus we're going to say negative 5 over 4. We're going to square this minus the same expression, negative 5 over 4 squared. Okay, then we solve. We have 2, the one that we factored out. We put the ones that are in the brackets, the ones with the squares in one bracket. So that, what are we going to have? We are going to have x minus 5 over 4, this squared. We're going to ignore the one that we have, and we have a minus. Now the square root of negative 5 squared, that is just a 25. Okay, then the square root of 4, that is an 8. Okay, so that's what we are going to have. Now what do we do? When we reach here, we would have expressed it in our form a, x plus p, this is squared plus q. Okay, although we're not graphing, but I must mention this. Okay, so your a is the coefficient, which is your 2. We found that. Your x, just the value of x. So that's what you're going to do. Now the p in this case, it shows you the shift in the x direction. Okay, the value of x, where it's going to be. Okay, so that is the shift in the x direction. Then your q in this case is the constant. The constant will tell you the shift in the y direction. Now where you have the shift in the x direction and the shift in the y direction, it will give you a point. That point is called the turning point. Okay, now the turning point, the way you find it, it will be negative p comma q. Okay, so that's how we're going to find the turning point. I just thought of mentioning that as we proceed. Let's look at the next question. 8x minus 2x squared. Okay, so let's just solve that. So we are saying our question is 8x minus 2x squared. Okay, so what are we going to do? So let's first rearrange it, okay, in a normal form, which is negative 2x squared plus 8x. Okay, so what are we going to do? We factor out the negative 2. So we'll factor out the negative 2, remain with x squared. Here we have negative 4x. Okay, hope we are cool, because when we multiply 2 with everything, it should take us back to where we are coming from. Okay, that's what we're doing. Okay, so let's just do that. Okay, so now what are we going to do? Again, just like the previous one, we half this and we square it like that. Okay, now the half of negative 4, or 1 over 2. Okay, what are we going to have? That will just be a negative 2. Okay, so what are we going to have? We have a negative 2. We open our brackets, so we have x squared minus 4x minus 2, let me say, okay, to be plus, okay, minus 2, this is squared, minus, again we're going to say minus 2 squared. Okay, then we are going to simplify this. So we have a negative 2. We have let's ignore this one and we put the x squared, the ones with the squares, in one bracket. So let's just do that. So we have x minus 2 okay, x, actually that is x squared. Okay, so instead of x squared, what are we going to have? Okay, so we'll have x squared, okay, minus 4. Yeah, because this is squared already. Okay, so what are we now going to have? Okay, then outside, what do we have? We've got a minus. The square root of 2 squared, that is just a 4. Okay, so now what do? We've got a negative 2 outside, so we are going to distribute that so that we have our final answer. So when the negative 2 multiplied by the coefficient of this expression, which is 1, so you just have a negative 2, then you have x squared minus 4 okay, x squared minus 4. Then on the other hand, the same negative 2 multiplied by the negative 4 there, what are you going to have? You have a positive 8. Okay, so if you want, you can, because there's a square here, if you want to remove the square, you can also do, you can say negative 2. You know, this is the difference of 2 squared that is in the bracket, so you can just say x minus 2 squared plus 8. Hope we are good. If I say x squared minus 4, that is just x squared minus 2 squared. Okay, so that would be the difference of 2 squares. Okay, that's what I've just done, because we want always it to be in that form. Okay, very, very important. It's good that we had such a question. So we've expressed it in the form a x plus p, the square is outside. Okay, don't leave it here, plus 8. Okay, or plus let me say plus q. Okay, so that's how we solve that one. Are we done with the first question? Okay, we're done with the first question. Let's go to the second question. Write the following expression in the form ax squared ax plus h. Okay, that's the form that we've been talking about, where a, h and k are constants to be found. Okay, write the form in the expression. So just like the first ones, we're writing them in that expression. So let's start with the first one. We've got 2x squared plus 8x plus 1. So it's the same procedure. We're going to factor out 2. So when you factor out 2, we have x squared plus, that would be 8 over 2. That is just what are we going to have? We have a 4x. Okay, for me to avoid fractions, okay, this is what I'm going to be doing. This is 4 over 2, 8 over 2, that is just a 4x. Okay, then we have plus 1 over 2, if I'm going to do that. But I can also do where I just get, if it's 2x plus 8x plus 1, I can just choose to factor out these to avoid fractions with the constant. So I have 2x squared plus 4x. Then I'll be going away with the 1 will be at the end, because I'm trying to avoid the fraction. Okay, so if I solve this one, what am I going to have? I have my 2 there, then I'm going to half this one and square it. Okay, so what am I going to have? It will be a 2. Okay, so because it is a 2, in the bracket of x plus 2. Okay, because I was minusing that, so the minus 2 squared, I have the minus, then the positive 2 squared, that will just give me a 4, right? So a 4 like that. Okay, then there's it will be like that. Then you'll be going away, you'll be going always with a 1 like that. Then what I'm going to have, when you distribute this, it will give you 2x plus 2. Okay, don't forget the square here. Okay, so this is square. Then when you multiply your 2 and your 4, you are going to get a negative 8. Okay, plus, now that's when now you put the plus 1, because you've distributed the 2. So now you have 2x plus 2 x squared minus negative 8 plus 1, that is just a 7. So that would be your answer. So even in this case, it's the same method that we are going to use, but now we are distributing throughout, but I was just trying to avoid the fraction. So I'm going to say 2x squared plus the 4x, the half of 4, that is a 2. Okay, so I'll say plus 2 squared minus 2 squared plus your half. Okay, it's the same question that I'm solving. Okay, so what am I going to have? I'm going to ignore this part and I'm going to get those on the squares in one bracket. Okay, so I have a scenario where I have x plus 2. Okay, x plus 2, this will be squared, then minus the 2 squared, that is just a 4. Okay, so that would be a 4 plus my half this side. Then what am I going to have now? When I do that, so I'm going to add 4 plus half. Okay, so if I say 4 plus half, what am I going to have? If I say negative 4 plus 1 over 2. Okay, so if I want, I can change this negative 4 to be negative 8 over 2. It's just the same, right? So it's just the same. If I say negative 8 over 2, it will see, if I say negative 8 divided by 2, it still give me negative 4, right? All I want is just to have the common denominator. So negative 8 plus 1, that is a negative 7 over 2, right? Okay, so that would be our answer there. So I'm going to replace that on that part. So the fraction is giving me, negative 7 over 2. So I have a 2 x plus 2, this is squared, minus 7 over 2, the answer that I found. Okay, so now what am I going to have? Now when I distribute the 2, it will be 2 multiplied by the coefficient of x, which is just 1, right? The coefficient of that expression, which will just be the same expression, x plus 2 squared. Then when I multiply 2 with that, okay, with negative 7 over 2, what am I going to get? Okay, so you just realize that your 2 and your 2 will cancel because you're multiplying, and you just remain with a negative 7. Okay, so you just have a negative 7. So this expression is the same as that expression. So from now on, I'm going to be using that. Hope we're on the same page. Okay, now let's solve the second question. Allow me to rub the first part that we've just solved. Okay, so let's solve the second question. So the second question is 5x squared minus 15x plus 3. Okay, so let's just do that. What are we going to do? We're going to factor out our 5. Remember, I'm going to leave out, I'm going to be going with this one, so I'll leave it. So I'll just factor this part, okay, to avoid a lot of fractions, a lot of them. Okay, so what am I going to have? Our 5 x squared. Okay, let me just use a different color. Our 5 x squared minus 3x plus 3. Okay, then now we complete the square. So what are we now going to have? We'll have 5, and we'll have our x squared, we'll have our minus 3x, and when we do that, what are we now going to have? The half of negative 3. The half of negative 3, negative 3 multiplied by half, that will just be the same, negative 3, right, over 2. Okay, so now you're going to square this. Okay, so when you square that, you will have negative 9. Okay, let me say, yes, when you square that, so okay, let me just put it there. So plus negative 3 over 2 squared. Then I'm going to minus with the same, negative 3 over 2 squared. Okay, that's that expression that I've done. Then I'm going to put this in the whole bracket. Then we'll go all along with our 3. So our 5. Okay, let me also put a bracket here. Okay, so our 5. Then what would be that? So we're going to ignore this part, and those ones, the squares, we'll put them in one bracket. So we have x minus, let me say x minus 3 over 2. This is squared, okay, minus the square root of negative 3. The square root of negative 3, I'm using this expression, that will just be a 9, okay. Then the square root of 2, that will just be a 4. So I'll close, plus our 3 outside. So let's just do that. What are we now going to have? Okay, so when we now distribute big numbers, okay, let's distribute. So we have 5 x minus 3, okay, minus 5 multiplied by 9 by 5 multiplied by 9 over 4. That would be 5 multiplied by 9, that is 45 over 4. Okay, then we have a plus 3 outside. Okay, so now what are you now going to do? So you just have to make sure that you solve the fraction. So when we solve the fraction, so we have negative 45 plus 3 over 4. Okay, over 4. So again, I can just manipulate our 3. If I manipulate our 3 will be the same as what? 12 over 4, right? Yes, 12 over 4. Just to make our work easier. So this is 4. Then this one we're saying is 12 over 4, because it's the same thing, right? So I have a common denominator, negative 45 plus 12. Okay, negative 5 minus 2, that is a 3. 4 minus 1, that is a 3. So we have a negative 33 over 4. Okay, so this whole expression is a negative 3 over 34. Therefore our final answer will just be 5x minus 3 over 2 minus 33 over 4. Okay, so this will be our final answer. We've expressed it in the form, this one, a x plus h plus k. Okay, our a is 5x, our h is negative 3 over 2, our k is negative 33 over 4. Okay, so that's how you solve that one. Then how do you solve the other ones? Okay, it's the same principle, nothing changed, or nothing has changed. Okay, let's solve the third one quickly. 3x squared plus 2x minus 1. Okay, so what are you going to do? You factor out the 3. So you have 3. I'm going to use the same method that I used. So 3x squared plus 2 over 3x. I've only factored out that part. I'll just go along with the negative 1 to avoid a lot of fractions. Okay, because of space. So what are we going to now have? We're going to say 3. You find the half of that. So the half of 2 over 3. So I'm multiplying this by half. Okay, so what are we going to have? We're going to have 2 over 6. 2 over 6 is just the same as 1 over 3, right? Yes. So we're going to square that. So we're going to have x squared plus 2 over 3x plus 1 over 3, this is squared, minus 1 over 3, this is squared. Okay, don't forget your minus 1 outside. Okay, so we do that. So now what are we going to have? We'll have our 3, okay, those ones, the squares, we put them together, so we have x plus 1 over 3, this is squared, okay, minus 1 over 3 squared. What are we going to have? The square root of 1, that is just 1, the square root of 3, that is a 9, okay, like that, minus 1, okay. So now what do? We distribute the 3, so we have 3, you have x plus 1 over 3, this is squared. When you multiply your 3 multiplied by 1 over 9, 3 will just be dividing into 9, right? So you have minus 1 over 3, okay. You have a minus 1 outside, now it comes. So now let's solve this one. We've got negative 1 over 3 minus 1, okay. Okay, so how can we also manipulate the minus 1? How can we manipulate the minus 1? We've got negative 3 over, we've got negative 1 over 3 minus 1. We're saying minus 1. So how can you manipulate the minus 1 so that we have at least the same denominator outside? So minus 1 will just be the same as minus 3 over 3, right? Yes, it will give us the same. So we have just a common denominator 3. So then we just add the one that's on top. Negative 3, negative. So we have a negative 4 over 3. So in that regard, our final answer expressing it in that form, we have 3. We have x plus 1 over 3. This is squared minus 4 over 3. So this will be our final answer. So you do that. It's the same thing for this last question. Okay, let's go to question number 3. Okay, given that x squared plus 3x plus 6 is equals to x plus h, the whole expression is squared, plus k, find the values of the constant h and k. Okay, so we're just trying to find let me say the turning point in that case. That's what I can just call them, because h will be the shift in the x, k will be the shift in the y, which will give us like our turning point. Okay, so what are we going to do? We've been given an expression. Okay, this is very straightforward. So we have x squared plus 3x plus 6. Now when you solve this equation, it will give you an answer, right? That answer, after you solve, probably using the completing the square, to give you x plus h squared plus k. Okay, so now what are you going to do? It's just a matter of equating, the two equations. So let's expand this one just to reach us to where we were. So what are we going to do? So write our x squared plus 3x plus 6 on the other side. Then when you expand this one, okay, so remember, if I've got a plus b, then this is squared. So the simpler way, you square this one, you also square that one, then you multiply 2 multiplied by a multiplied by b on the middle. Okay, so when we do that, what are we going to have? If I say 2 multiplied by a, that would be a squared, right? Then I also multiply 2 multiplied by b, so I multiply 2 by a, that is a squared. Then when I multiply 2 by b, that will be b squared. So I'll put plus because there's a plus sign, and I'll put plus on the other side. So then I'll multiply 2 multiplied by a, that is 2a. 2a multiplied by b, it will be 2ab. So this will be 2ab, like that. So that's how you easily, solve that. But if you want, you can multiply. You start like from the first one. You are multiplying one by one. You can do that, but you are not going to do that in this time. So we're just going to say x squared. When we multiply 2 by x squared, it will be x squared plus 2 multiplied by x, that is 2x multiplied by h, that will be 2xh, so it will be 2xh plus h squared, okay, plus k. I've just expanded that one. So now what do we have? Now what do? We can compare the coefficients of x. Okay, you're able to see that x squared and x squared, they're just the same like that. Okay, so we are good on that one. Then your 3x and this expression, this one, the one that has x, they are equal. Okay, then your constant 6 is equal to that. Okay, so let's just do that. So you know that your x squared and this one is just 1, right? Or that one is just 1. Okay, so because all of them are 1, so we're going to say a squared is just equals to 1. Okay, so it means now the value of x in this case will just be equals to 1, right? Okay, now we also have this 3x and this one as 2hx. So let's ignore the x, so here we have what? We have 3 is equals to 2h when we ignore the x. Okay, so what are we going to have as our h? When we divide, but to remain with our h will just be equals to 3 over 2. Okay, now the last expression. So now what do we have? Okay, what other expression do we have? We've got 6 will be equals to this expression x squared plus k. Okay, yes, x squared plus, that's the constant. So what are we going to do? So say 6 is equals to h squared plus k. So in this case we're going to say 6 is equals to, we found our h, so to be 3 over 2, that's our h squared plus k. So 6 is equals to the square root of 3, that is a 9, divided by the square root of a 2, that is a 4. You are adding this plus k. Okay, to remain with your k on the other side, you're going to say k is equals to, you take the negative, you're going to have 6, 9 over 4, when you take it to the other side, it becomes a negative, right? So it will be subtracting, so I have minus 9 over 4. Okay, so you just have to solve that. So we have 6. Okay, let me just write it, allow me to write it here. So you have 6 minus 9 over 4, let me say over 1. Okay, when I divide that 1 into 4, that is 4. 4 multiplied by 6, that is a 24, minus 4 into 4, that is 1. 1 multiplied by 9, that is 9. So 24 minus 9, 24 minus 9, that is about 15 over 4. Okay, 15 over 4. So therefore the values of h and k, what are we saying? The values of h and k. So the values of h and k, so the value of h, we found that it is 3 over 2. Okay, then the value of k will just be 15 over 4. So that's how we solve that one. Let's go to the next question. Question number 4. Write each of the following function in the form that, okay, we've been expressing this form like so much. Then we sketch each function indicating the turning point and the points where the function cut the coordinate axis. Okay, this is an interesting question. I like graphing functions. Okay, so to write the function in that form, you always know that you have to complete the square. Okay, so let's start with the first one. We have x squared. We're saying f of x is equals to x squared minus 6x plus 8. Okay, so what are you going to do? Okay, we've been completing the square. So what are we going to do? So we're going to just say f of x will just be equals to again, it's the same thing. You factor out here because the coefficient is just 1, you square. So what I'm just going to do it direct. Okay, so what are we going to have? We have x, the half of 6, that is a 3. Okay, when I square that, it will be negative. So of x minus 3, this will be squared. Okay, then I'm also subtracting by negative minus 3 squared. 3 squared, that is just a 9, right? Okay, so I have a 9 plus 8. Okay, so what am I going to have? This is the simplest form. Okay, what am I going to have? So I have x minus 3 squared negative 9 plus 8, that is just a negative 1. So this will be your simplified form. Okay, so now what do you have? So your turning point, like I earlier said when we're introducing, we said the turning point is just equals to negative p comma q. So in this case, your value of x is negative 3, so negative and negative will give you a positive. So you have a 3 comma, the value of q, just get it the way it is, that is negative 1. So this will be the turning point. It will be the shift in the x and the shift in the y. The turning point, that's where your graph starts from. Then you also have to look the value of x. The value of the coefficient of x here is greater than 1. So because the coefficient of a is greater than 1, your a is greater than 1. When your a is greater than 1, you are going to have a minimum graph. Okay, a graph that looks like that. So let's just draw that. Okay, so let's graph. Let's say this is our graph. This is the y-axis, this is the x-axis. Okay, allow me to draw it from that side. Okay, so what are we now going to have? Okay, so the only thing that we have here is a turning point. Okay, 3 comma negative 1. Let's say negative 1 is here, let's say 3 somewhere there. So let me say 3 somewhere here, and so therefore maybe our turning point will be there. Okay, then what else do we need to find? We also need to find if it cuts the y or x axis. Okay, so where will be our turning point, or where it's going to cut the y-axis? On the y-axis, this line, on the x-axis, y is equals to 0. On the y-axis, x is equals to 0. Okay, so you have to know that. So now let's find where it's going to cut the x-axis, the y-axis. So we're going just to set x to be equals to 0 in the function itself. So you have there you have 0 squared. So here you have 0 squared, 0. When you solve the expression, you're just going to remain with 8, right? So it's going to cut the graph at 8. Okay, so this, let's say 8 is here. Let's say 8 is here, and that is our point. Okay, so it's going to cut there. Okay, so now we're able to see that our graph, the way it's going to go, it's going to come from this side. Okay, it passes through, it cuts there, it passes through the turning point, and it goes like that. Okay, now it has cut the x-axis at this point, and at that point you have to find those points. Okay, so what are you going to do? You set the whole equation to be equals to 0. Okay, your y should be equals to 0. So y, which is f of x, will be equals to, now I'll get the simplified version, this one that we found. Okay, because we've reached that step. So we're going to say x minus 3 squared minus 1. So I'm going to take the negative 1 to the other side. Of 1 is equals to of x minus 3 squared. Then I'm going to the square root on both sides so that I cancel the square. The square root of 1 on the other side will just be 1. So allow me to rub this point because we've already found that. Okay, so the square root of 1 will just be 1 is equals to the square and the root will cancel, so you're just going to remain with x minus 3. So we're going to say yes, you're going to remain with that. Okay, so you have a positive or minus 3. So what are you now going to do? You're going to take this would be, yes, the square root of that. Yes, so when you take the negative to the other side, or the square root of 1 is positive or minus 1, right? Okay, Yes, positive or minus 1. So I'm going to have positive or minus 1. When the negative 3 goes on the other side, becomes positive, right? So I'll have a positive 3 is equals to x. So these are the values of x. So therefore x will be equals to 1 plus 3, that is just a 4. Okay, yes, 1 plus 3 is equals to 4. Another x value will be negative 1 plus 3, that will just be a 2. So these are the values. So 2 will be here and our 4 will be there. So this is a graph of x squared plus 6x plus 8, like that. So that's how you graph that one. Okay, so we can graph we can also graph the second one. Oh, which one can we graph? Okay, anything that has let me say that can give us a good one. Let's solve no, I want something that has a minimum. Okay, let's solve the last one, this one which is with a negative. Okay, I want something with a maximum. Okay, so let's solve that one. Allow me to rub. So all these other ones with positives, the value of x, the coefficient of x squared is positive, they will just be minimums, like that. Let's solve something with the maximum. Okay, let me solve vi. So we have f of x is equals to negative x squared minus 6x plus 8. Okay, again you're going to do your completing the square, okay, because you want that form. So in that case you're going to say f of x will just be equals to in that regard, what am I going to do? I'm going to again do the same, just factor out this side. So I'm going to factor the negative 1, so I'll remain with x squared. So this would be what? To be plus, right? Then the half of negative 6, that is just a 3. Okay, it will be a negative 3. Yes, the half of 6 will be negative 3. Then when I square that, okay, when I square that, so I'm going to have x, I'm going to have x plus, okay, let me first write it nicely. So when I factor out the negative, I have 6, I remain with 6x. Okay, then there's a plus 8. Okay, that's how it is when I factor out the negative. Then I was saying, so it would be negative 1 x. Okay, now the half of 6, that is a 3. Okay, then I square that. So I'll put the ones with the squares in the bracket. So x plus 3 squared, then minus the square of 3, that is a 9, right? So I have a 9. The square of 3, the square, yes, it will be 9. No, now that is, yes, a 9. Then what are we now going to have? Yes, a 9. Yes, plus 8. Now this 9 is like that. Okay, because the 8 has to go throughout. Okay, so I've now, when you distribute the negative, when I distribute the negative, I'll have negative, it will be x plus 3, this is squared, the negative multiplied by the 9 there, you give me a positive, right? So I have a positive 9. Then that's when now you bring out the 8, okay, plus 8, like that. So in this regard, you have negative, you have x plus 3, this is squared, 9 plus 8, that is just 17. Okay, so therefore what will be our turning point? Our turning point in this case will be what? It will be negative 3, okay, comma 17. Okay, so now let's graph this one. How do we graph it? Okay, allow me to graph from here. Let me say this is our graph. Okay, so you know all the axes. So now we only have a turning point. So the turning point, allow me to wrap this part. Let me only leave the equation that we found because it will help us find where the graph, if it's going to cut the x-axis. So our turning point, we've got -3. Let's say -3 is here. Let's say our 17 is somewhere there. So this would be a point. That's where our graph is going to start from. Now, is it going to go upward or downward? That's the question. Okay. Now you have to look at the value of x. Okay. The value of the function, it is a negative. Okay. You're able to see. So because it's a negative, your graph is going to go down to the negative values. Okay. And the other thing is your a, in this case, is less than 0. Okay, because when your a is less than 0, you're going to all the values that are less than 0, and those are negative numbers. So so how is the graph going to be? We also have to find where it cuts the y-axis. Okay, when I set the whole expression to be equals to 0, so this whole expression, if wherever there's x, I put 0, you realize that I only have an 8 at the end, right? So to cut, let's say our 8 is somewhere here. Okay, let me just put the point there. Okay, so it means our graph is going to go past there, to pass through the turning point, and it will pass through 8, and it will go like that. Now it's cutting the x-axis at 2 points, this point and that point. So we have to find those 2 points. So like we earlier did, we are going to say 0 is equals to, we get this same expression that we found as our answer. So I have negative x plus 3, this is squared, plus 17. I'm going to take the negative 17 to the other side. Okay, so I'm going to take the 17 to the other side to be negative 17 is equals to negative x plus 3 squared. Then I'm going to divide by the negative on both sides, right? When I do that, what am I going to have? I have a 17 is equals to x plus 3 over 2 squared. Okay, 3, then the square outside. So to remain with this, to cancel the root, so I'm going to do that. So the 2 and the root will cancel. So I just have x plus 3 is equals to the square root of 17. Okay. Now, what am I going to have? The square root of 17 need to be a positive or minus, right? Okay. Then the negative 3, I'll take it to the other side. So x will just be equals to negative 3, positive or minus the square root of, 17, like that. So in that regard, the 2 points that we're going to have, since I don't have a calculator, I'm going to put this point that we found, this will be negative 3, negative the square root of 17. Then this other one would be negative 3, positive the square root of 17. Okay, so that's how you solve that graph. Okay, very, very important. Then let's solve the next question. Sketch the graphs of the following functions. Okay, it's the same principle. You're just doing the same thing, okay, like we just earlier did. You are using completing the square and you graph them. Okay, very, very important. So what can we do? Okay, it's the same thing. Let's go to question number 6. If we're going to find something different, find the values of k for which the equation 2x squared plus px plus 1 is equals to 0 has one real solution. Okay, so this is an interesting one. So 2x, they're saying 2x squared plus px plus 1, this is equals to 0, has one real solution. Okay, so what are we supposed to do? It has one real solution. So we're talking about the discriminant here, right? The discriminant is what is in the root of the quadratic formula. Okay, the b squared minus 4ac, this is your discriminant, the one that is in the root of that quadratic expression. So now when they say there's only one real solution, So it means the equation should be equals to 0, right? So what now are we going to do? So let's get the values of a, b, and c. So we're going to say our a in the expression is what? Is 2. Our b in the expression is what? Is p. Our c in the expression is what? Is 1. Okay, so the discriminant therefore will be to find the discriminant, we are saying it's b squared minus 4ac. So we just replace our b squared, that is p, right? So p squared minus 4, our a is 2, our c is 1. Okay, so what are we going to have? So we have p squared is equals to minus 4 multiplied by 2, that is 8, 8 multiplied by 1, that is 1, that is 8. So we have 8 here. Okay, so now what do we so now when the discriminant has one solution, so these are the conditions that you're supposed to know. When your discriminant b squared minus 4ac is equals to 0, it means it has one real solution. Okay, let me just put it like that. Then if your discriminant b squared minus 4ac, this is, let me say it is less than 0. Okay, when it's less than 0, these are the negative numbers, right? So you have a complex, you have two complex roots. Okay, but if you have b squared minus 4ac, this is greater than 0. These are the positive numbers, so it means you have two real solutions. Okay, two real solutions. So now in this case, because we are saying it has one real solution, because if in that square you find that your answer, because we're saying it's equals to 0, right? If in that square you find 0, the square root of 0 will just be 0. Then you have a positive or minus. So 0 can either be a positive or a minus. So you only have one answer for this expression. Okay, that's what we're talking about. So this expression that we found here, it will just be equals to 0 because they've specified it is one real solution. So we'll put 0. So now we solve that. So how are we going to remain with our p? I'm going to take the negative 8 to the other side. So our p squared is just equals to, with the negative 8 goes to the other side, will be a positive number, right? So I'm going to now square on both sides. Okay, so our p therefore be equals to the square root of 8. Which two numbers? Let me say which two numbers can we multiply to give us 8? 2 multiplied by 4, right? We've done suds. The square root of 4, that is a 2. So to have a 2 root 2. So this will be positive or minus 2 root 2. So the values of p, they will be 2. Okay, you have two answers. You have p is equals to negative 2 root 2, and p will be equals to positive 2 root 2. So those will be your solutions. Okay, let's go to the next question. Find the values of k for which x squared plus 6x plus k is equals to 0, and this has two real solutions. Now they've just said two real solutions. Okay, so because they are real, so we're going to combine our first expression. Let me say we're going to combine when they've just said real solution, because even one is the real solution. Okay, two real solutions, even these ones are solutions. So if they haven't specified 1 or 2, so we're going to combine these ones. So we're just going to put a greater than or equal to there. Okay, so let's just do that as two real solutions. Oh, actually they've said two real solutions, even greater. Okay, so what are we now going to do? So your discriminant b squared minus 4ac. Okay, let's find the values of a, b, and c in our equation. So what is our a in our equation? Our a is 1, our b is 6, our c is k. Okay, so then we replace. So our b, we are saying it is a, so that will be 6 squared minus 4. Our a is 1, our c is k. So we are going to have 6 squared minus 4 multiplied by 1, that is 4. 4 multiplied by k, that is 4k. So we have a 4k. Okay, 6 squared, that is just a 36. So we have a 36 minus 4k. Okay, this is the expression that we have. Now we're saying because when you're talking about two real solutions, this O expression should be greater than or equal to 0. You want positive numbers. Okay, so it means you're going to solve this inequality. Okay, when you're solving inequalities, what are you going to have? So you have negative 4k is greater than or equal to, when I take the negative when I take the positive 36, the other side will be negative, right? So this side we have negative 36. Okay, then we divide by the negative 4 on both sides to remain with our k. Now from your rule of inequalities, you can watch our videos on inequalities. What are you going to have when you're dividing by negative? We're going to say k, the inequality changes the direction, so k will be less than or equal to negative 36 divided by negative 4, that is just a 9. Okay, so the values of k for which the quadratic equation x squared plus 6x plus k is equals to 0 has two real solutions would be k is less than or equal to 9, like that. You want all those values that are less than or equal to 9. Okay, very, very important. Now let's solve the next question. Question 8 is saying the equation x squared minus 4kx plus 4 is equals to 0 has two distinct real solutions. Find the set of possible values of k. Okay, so we're finding the possible values of k. So it is the same, the equation that has two distinct, find the set of possible values of k. Okay, very interesting question. So to determine the set of possible values of k for which that quadratic expression has two distinct, we have to also again make sure that the discriminant is positive, right? Because we're saying two distinct real solutions. Okay, so yes, so what would be the values of a, what would be the values of b, what would be the values of c? Okay, let's just write that to guide us. Our a, in this case, you're able to say that it is 1, right? Then the value of b, that is the coefficient of x, we would negative 4k. Okay, then the value of c, that is just a 4. So now let's do that in the discriminant. The discriminant is b squared minus 4ac. So let's replace b, that is negative 4k. This expression is squared minus 4. Our a is 1, our c is 4. So when we solve that expression, what do we get? The square root of negative 4, that is 16, right? Then k will be squared. Okay, minus 4 multiplied by 1, that is 4. 4 multiplied by 4, that is a 16. Okay, now we are saying has two distinct real solutions. When they say distinct, these are two different real solutions, so meaning 0 is not included. Okay, so in this case we are saying this expression should be greater than 0. Okay, should be greater than 0. You want two distinct real solutions. So now what do we do? How do you solve inequalities now? So how are we going to solve this one? We can factorize 16 because it's common on both sides. So we're going to say 16, you remain with k squared minus 1, right? Okay, this is greater than 0. Okay, now what do we do? So it just be 16 is equals to 0, or when you divide by 16 on both sides, 0 divided by 16 just give you a 0. So you have k squared minus 1 is greater than 0. Okay, now k squared minus 1 can also be squared, doesn't even affect anything. When you square 1, it becomes a difference of two squares, right? So it will be k minus 1 or k plus 1 is greater than 0. So what are we going to have as the values of k? So we say k will just be we're saying k minus 1, right, is greater than 0. The other one is k plus 1 plus 1 plus 1 is greater than 0. So the values of k, what would be k? K will be, because where the negative 1 goes on the other side, it just be positive. So k is k will just be greater than 1. So k will be greater than 1. Then the other one is k will be greater than negative 1. Now what will be our solution set, because they'll be asked us to find the set of possible values of k. Okay, so what are we going to do? We know how we solve inequalities. If you don't know, you can still access our videos. It's there just on YouTube. Type Novastone Academy, rational inequalities. You're going to find those, or just even inequalities. It's going to come. Okay, so let's draw. Okay, let me put, we've got two values of k, right? Okay, so in that regard, what do we have? Let me say this, since we only have two, so I'll put that is big, I'll put like that, I'll put like that. Okay, let's say this is like our number line. Okay, this is for the first equation, second equation, then now have our product there. Okay, so now what do we now do? Okay, so so let's start with so of negative 1. The other expression was what? The other expression gave us 1. So this will be the demarcation of signs. They'll be telling us where we're going to be falling. So what were answers? What equations gave us those expressions? We had k minus 1 and we had k plus 1. Okay, these ones were multiplying, so this will be the product, right? Okay, the product of the signs. Okay, so our expression was, don't forget this one, so it was k, because we had done the difference of two squares, so it was k minus 1 and k plus 1. This should be greater than 0. Now let's start with the first one, this one. Which one gave us a negative 1? Okay, so the one that gave us a negative 1 was k plus 1. Now in k plus 1, if you get any value of any value that is above negative 1, let me say a 0. If I put a 0 here, what am I going to have? I'm going to have positive numbers, right? So here, numbers greater than negative 1. Oh, actually, I'm supposed to write on top because that's the equation that gave us that. So numbers that are greater than 1 will give me positive and positive. But if I get a number that is less than negative 1, let me say a negative 5, and I put there, what am I going to have in the equation? If I put a negative 5 here, I'm going to have a negative number. Okay, so in that regard, so this would be negative. Okay, then which equation gave us 1? It is k minus 1. Okay, so if I get any number k minus 1, okay, if I get any number that is greater than 1, let me say 2, I plug in the equation here, I'm going to have what? A positive number, so I have a positive number. If I get a number between negative 1 and 1, let me say a 0. Negative 1, yeah, let me say a 0. I'm going to have a negative number, right? So here will be negative. If I get any number that is less than negative 1, maybe negative 5, it will still give me a negative answer. So even this area will be a negative. Now these ones are multiplying, okay? They were multiplying. So what are you going to have? Negative multiplied by negative, that is just a positive, okay? A positive multiplied by negative, that will just give us a negative. Positive multiplied by positive, that will be a positive. Okay, so now which numbers are greater than 0? Because we're saying this whole expression should be greater than 0. Okay, so now which numbers are greater than 0? Positive numbers, right? So our solution set, therefore, our solution set will therefore be what? Okay, so now because it is not equal to, you have to be very careful here, because there's no equal to here. So what are you going to do? You're not going to include all the values, right? Okay, so it means here you're going to put an open. Okay, you're going in this direction. Okay, good. Then other positive numbers, oh, this is positive. Other positive numbers, it is from here you're going in that direction. Okay, so therefore what would be our solution set? Okay, our solution set, let me say SS, or our solution set will just be equals to, you want all the numbers from negative infinity to negative 1. Negative 1 is not included. Okay, union from 1 to positive infinity. Okay, you are done like that. That will be your solution set. Or the answer that we found can guide you. You want all the values of k is less than 1, okay, or k is greater than 1 and k is less than negative 1. Okay, so those are the values. So that's how you find your solution set. Okay, so is there anything that we can now solve? Okay, let's go to question number 9. Find the range of values of k for which 3x squared minus 12x plus k is greater than 0 for all values of x. Find the range of all values of k. So we're finding the range. The range is the y values, right? Okay. So to first find the range, we need to ensure that the quadratic expression is always positive. Okay, because we want all real values. Okay, so how can we now write that one? It means we have to first solve it, so that we have to solve it in form of what we call it, the completing the square. Okay, so when we solve that using completing the square, or is it even necessary if we do completing the square? Not really, like really. So because once find the range, you remember you have to know where. You remember I was talking about the turning point. Okay, the turning point, that's where the graph starts from. Okay, so that would be a guide. So on the turning point, you can solve the whole expression so that it gives you, it helps you find the turning point. But the other formula that you can use for finding the turning point, if you want to find the x value to be x is equals to negative b over 2a. So in this expression, negative, our value of x in that case is negative 12, right? Okay, negative 12, right? Over 2, our a there is what? Is 3. So we're going to say 12 over 2 multiplied by 3, that is a 6. So the value of x will be 2. Okay, at that point, at the turning point. Then what about the value of y? So you are going to get the same expression, and wherever there is x, you are going to be replacing 2. Okay, to find the value of y. So we're going to say 3, where there's x we're putting 2, so it will be 2 squared minus 12 2 plus k, this is greater than 0. Okay, or let me just say it is equals to 0. Okay, so it will be 3 2 square, that is just a 4, right? Minus 12 multiplied by okay, let me just see, 3 multiplied by 4, that is just a 12. So I can just put it in advance. So this is 12 minus 12 multiplied by 20 by 2, that is just 24, plus k, this is equals to 0. Okay, let's solve this one. What are we going to have? 12 minus 24, that is a negative 12, right? So I can write it as k minus 12 is equals to 0. Okay, now there is an inequality, right? So you can say k minus 12, this should be greater than 0. Okay, because we all want to do solutions. Okay, so what now do we do this is an inequality, so our k will just be, it will be greater than the 12. When it goes on that side becomes a positive. Okay, so what this shows you is that, because this what we found, it is the value of y, okay, at the point of y. So that's where the graph will start from. So the graph is going to start at 12, at 2 comma 12. Okay, and they've told you real values. So you want all the values that are positive. Okay, so where are you going to start from those positive numbers? For x, you're going to start at 2, going all the way to infinity, or to positive infinity. For y, you're going to start from 12, going all the way to positive infinity. So what are we talking about? You want all the values of k that are greater than 12 until to wherever you're going to end. So this is where we're going to end from this session. And don't forget to subscribe and follow our our page, and also like this video. See you in the next session. Thank you.